So we're talking about Lewis dot structures in regards to covalent compounds. So we talked about it a little bit in our Edpuzzle. We've talked about the Lewis dot structure with naming covalent compounds, but I wanted to do it with practice. Warm-up questions, I kind of want you to do it on your own. Remember, they're based on their group for a valence electron. Remember, valence electrons does chlorine have? So before any bonds, if we look at chlorine, it's in group 17, so we know it's 7, and you can go based on that. I want you to name the rest of these on your own, but we will go into discussing how we do the steps for the covalent bonds. Now, step 1, you add up your total number of valence electrons. So however many valence electrons are in that. You want to see how many you're going to have when you base it all together. Step 2, you'll draw the skeleton of it. And step 3, you'll add the rest of the valence electrons that are not bonded. Remember, skeleton just shows the single bonds from each one, or the double bonds based on what you need. Single bonds, and then we'll go into double bonds as we go along. Now, if you can tell, if there's a need for, so say we go into it, if there's any leftover, we go into it. If we see that we need to have more bonds, we add those in there as well. All right. So, moving on. Let's try one together. Covalent bonds. So carbon, tetrahydrogen, or tetrahydride. We're looking at a total number of electrons with H equals 1, so 4 times 1 equals 4, and then C equals 4 times 1 equals 4. We add them together, we have a total number of 8. The central atom is going to be our carbon for this particular one, and if we show the Lewis dot structure, we're going to have carbon, hydrogen, 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 hydrogen. So we see that there's bonds here, bonds here, bonds here, and bonds here. Now, if we see this, we see that there are, remember, each line counts as 2 electrons. So we have 2, 4, 6, 8. We had 8 total. Hydrogens are all filled up. Carbon is all filled up. So that means there are 0 lone pairs and there are 4 bonded pairs. Okay? Now, I want you to do the rest of the non-honors by yourself. So I want to do one together, or we'll do a couple together as the honors, just so you get the idea. So hydrogen and oxygen, we have hydrogen, which equals 1 times 2 equals 2. Oxygen equals 6 times 1, because there's only 1, equals 6. We'll roll down here, and we have 8 total. Now the central is going to be oxygen, because the hydrogens will bond to the oxygen, not the other way around, because hydrogen needs 1 each, and oxygen needs 2 total. So we'll have O, H, H. Now, remember, we have 8 total, and the hydrogens are filled because they have 2 each. So 2, 4, because remember our lines equal 2, what means we need for our oxygen 1, 2, 3, 4, because 1, 2, 3, 4, 6, 8, and that gives us what we need. Now bonded pairs, we see 2 lines, so there's going to be 2. Lone pairs, we see that there are 4 dots, which means that if we divide that by 2, we get 2 lone pairs. All right, and then we'll do one more together. Hydrogen is going to be 1 times 2, So that means equals 2 total. Our central, being that there are only 2 and there is no central, but we can count either one as a central because they're going to centralize. So the bond between the 2 is going to be central. Bond between the 2 2HR is central. Or we can just say no central atom. So we do our little combination, H and H. We see that there's 2 here. There's 1 total bonded. There are no lone pairs, 1 bonded. And it is that simple. So go through these up top and finish on your own. Okay? That is all for today.